Hello guys. Today I came up with a new project called All-in-One Numerical Solver. So this is a revolutionary computational tool which will be useful for engineering students to solve any sort of complex engineering problems. So still I'm in a developing stage. So right now I have mainly concentrated on Department of ECE with the help of computer science engineering. In the sense, I have used pyqt5 Python for this project. pyqt5 is mainly for graphical user interface and Python as a scripting language. So right now I'll be just going to the code and what I have done. So these are the libraries what I have imported. These all are related to pyqt5 framework, which is mainly a GUI framework. I also have a configuration file, and this ec.py is main thing where classes for each and every subject will be created. In a sense, for example, you can see a dictionary here, subjects data. So at this point, I have listed few subjects. So one of the subject is fundamentals of VLSI. In VLSI, the tools which I have written are threshold calculator, and this is background. So just let us concentrate on the dictionary, what main tools are here. Digital signal processing. In that, the tools, digital signal processing is a subject, and tools are DFT, IDFT, DFT properties. Till this extent, till now, these are the three properties what I have done. And in microwave and antenna, this is another field of engineering of electronics and communication, where the calculations for antenna is done. And digital communication, in digital communication field of electronics and communication engineering, sampling in SQNR ratio or SQNR data is much more important for any calculation or the transmission of a digital signal. So keeping that in mind, initially I have gone through very basic calculations. I'll just show you the demo and let us come back to the code understanding of the code. Before that, let us go to configuration file where I'll be showing you, I mean, like three to four steps of these things. So background is the main thing for I mean, like attractive GUI. So I have given a background with the path of the background here, and these are window size, A into B, A in the sense the width of the window, and B in the sense the height of the window. And this will be the font size and font type, enlarge text, and demo. This is just a configuration file what we'll be using. I mean, like a user can configure his tool for efficient and then like ease of working. So later on, when we go to ec.py, when I run this script, you can observe here. I just delete this and then so this is tool. What I mean, like this is the opening page of the tool. So here you can see here, this is the background. We can add any background here. So the first one is fundamentals of VLSI, digital signal processing, microwave and antenna, and digital communication. So at this point, I'll just go to digital signal processing and let us see. So when I open digital signal processing, I'll get DFT, IDFT, and DFT properties. So we can compute and then add much more, I mean, many more tools to this tool. Actually, this will be subtools of a single subject or single topic. So I'll just, for demonstration purpose, I'll go to DFT properties. So let me give a sequence here, 1 comma 1 comma 1 comma 1. And then I have given an option here to calculate different sort of properties. So I just click on calculate all so that uh, a student or a researcher or the faculty who needs these calculations will get complete data regarding the calculation what he she aims to do. So when I click on compute DFT properties, I'll get linearity, time and frequency reversal, conjugation, and these things. So this majorly helps students or researchers or faculties who doesn't require any sort of complex uh, steps. They just need the answers. And moreover, in further coming days, I'll be updating or using artificial intelligence. I'll be writing or designing a software which will also give the steps. So at this point, this works basically. I have designed this software in a very basic manner. So right now we don't have any computational extra computational algorithms or something like that. So I have given show formula so that the interaction of students or faculties who uses this will also be aware of formulas and how the linearity and these things are calculated. So later on in the next stage, if I show you, so if I click on digital communication network or the digital communication subject, so sampling and SQNR. So this tool is mainly designed for giving maximum like possible outputs or possible number of calculations or computations with minimal data. So if I enter minimal data, I'll get a maximum computations what all it can do. So for example, if I give the accuracy as 0.2 and peak to peak value as 2 and signal frequency as 100, I'll get as many as parameters as possible. So with only three parameters, we have calculated bit rate, bandwidth of sine wave, sampling frequency, step size, levels, number of bits required for that levels to be transmitted, and the SQNR ratio. So this is basically the main thing. I mean, like useful for engineering students of any department. In coming future days, I'll be enhancing this tool or expanding this tool limitlessly to other departments too. So for ease of this thing, so here like the basic block diagram is shown in the show formula. So at this point, if you don't have any formula list or something like that, I have just given a block diagram of digital communication. So you can see here digital source and something like this. So this is the tool. So now coming to the code part. So ec.py what here I have written is for mainly for the main page of the tool. So this tool is mainly based on pyqt5 framework. So pyqt5 framework in the starting page will only display subject list of subjects or something like that. Later on, if a subject is clicked, it then goes to another class called tools dialog. So at this point, the tools dialog will display, this is the logic for displaying the tools. If DFT property is clicked, if this digital signal processing is clicked or digital communication is clicked, or fundamentals of VLSI is clicked. Later on, like it pops up IDFT or DFT. I mean like subtools. It pops up subtools. So if subtools are clicked, I have written each and every logic for each and every tool here. So you can see here, this is for Fourier transform, sampling, threshold calculations. So, and this is for DFT properties. You can see the logic here. So logics are written here. For all these codes and stuff, you can directly uh, check out my GitHub repository where I'll be giving posting all this code directly into the GitHub repository. The link for GitHub repository will be given in the comments list. If you people have any sort of queries or doubts regarding the tool, or if you people intend to work on the same project or try to develop the same project, you can directly ping me in comment section down here. So that's all. Thank you for watching the video. Please subscribe. Thank you.